So from here, Falcon 9 has autonomous control of the rest of the count. The LD will give their final go for launch.
LD is go for launch.
Now the payloads continue to look healthy. Next major milestone coming up at T-minus 2 seconds when we ignite those Merlin 1D engines, and then liftoff at T0. We're about 30 seconds away.
T-minus 30 seconds.
Range and weather continue to look good. Let's watch.
$15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Full power. Liftoff of Iridium OneWeb.
Vehicles pitching downrange. M1D chamber pressure is nominal.
Successful liftoff of Falcon 9 from Space Launch Complex 4 East at the Vandenberg Space Force Base. We're carrying the Iridium OneWeb satellites into orbit. We've begun gimbaling the engines on the first stage. Gimbaling is really just tilting the engines.
Telemetry nominal.
We've begun what's called a gravity turn. So we're letting gravity help pull the rocket to go sideways. We need to be going fast horizontally to get into orbit. We actually just got through the throttle bucket.
Vehicle supersonic.
Throttle bucket being where we've throttled down the Merlin 1D engines in preparation for max Q. That's the point of highest stresses on the vehicle.
Max Q.
Fantastic views from this ground tracking cam. Nice to be out of the Vandenberg fog. Now, a rocket needs to go about 17,500 miles an hour horizontally in order to avoid being pulled back down to Earth. And if it does get to that velocity, that's what we say, that's what we mean when we say we're getting to orbit. So we're continuing to accelerate on the first stage. Call out there of MVAC chill. That's for the next several events we've got coming up. The first of those is main engine cutoff, where we'll shut down these 9 Merlin 1D engines on the first stage. That'll be followed by stage separation, where the first and second stages will separate from each other. The Merlin vacuum on the second stage will ignite at SES-1. And then we will have the fairing halves separate shortly after that around the T+3 minute mark. So again, those events back to back, MECO, stage sep, SES-1, and then shortly after, fairing separation.
MECO.
Stage separation confirmed.
MVAC ignition.
And there are great views of that shortened MVAC nozzle. Right-hand side of your screen is the second stage. Left-hand side of your screen is the first stage. We've begun deploying the hypersonic grid fins on the first stage. Those are those structures that are popping into view right now. Next major milestone will be a fairing deployment. If you keep a close eye out, you might even see those fairings behind the second stage as they trail away.
Fairing separation confirmed.
And there is successful separation of the fairings. Now both the fairing halves, in fact, there's a view of one of the fairing halves on the right-hand side of your screen, making its way back to Earth. Both of these fairing halves are flight proven, one of them having flown 3 times and the other one for its 6th time. And we will be attempting to recover both halves once they make it back to Earth using our recovery vessel named Go Beyond. T+4 minutes. If you're joining us, welcome. You're looking at a live view of Falcon 9. right-hand side of your screen is the second stage in the first of 2 planned Merlin vacuum engine burns. This burn will last about another 4 minutes on the second stage. It's carrying our 21 payload satellites into orbit. On the left-hand side of your screen, we've got Falcon 9's first stage. Those periodic white bursts that you're seeing are actually from our attitude control system. We're reorienting the first stage to get the engines pointing down back towards the atmosphere, because we're coming up on Falcon 9 first stage's next major milestone as well.
Both vehicles are following nominal trajectories.
Call out there indicating that we are on the path we intend to be on. Now, the first stage is pointing its engines down in preparation for the entry burn. Entry burn is where we relight 3 of the Merlin 1D engines on the first stage. We relight the center engine and then 2 of the radial engines. And that maneuver is to slow down the first stage. We've picked up quite a bit of velocity in lofting the second stage and getting it started on its path to orbit. And we're going to bleed off a lot of that energy as we come back through the thicker parts of the Earth's atmosphere. So rather than taking all of that heat loading and structural loading directly on the vehicle, we use some of our propellant to slow down a bit. And that's what the purpose of the entry burn is. Helps us reduce the stresses and loads on the vehicle to help recover it. View from the inner stage. Just a few minutes ago, we had a second stage in there. Now, all the soot that you see actually comes from a couple of different sources. The soot that we're seeing in the inner stage came a little bit from that second stage burn. The soot that you see on the rocket actually comes from the entry burn primarily. We're flying quickly backward through our Merlin exhaust plumes, and we use a carbon-based fuel. So as we combust that, that leaves a nice small layer of soot on the vehicle. And reusability is really what makes the cost of spaceflight lower and enables more scientific research and infrastructure development in low Earth orbit like we're doing today.
Stage 1, FTS was saved.
Stage 1 entry burn startup.
There is startup of the entry burn. This should be a pretty short burn. Falcon 9 making its entry burn for its 11th time, this particular booster having flown 11 missions. Total burn duration, just about 20 seconds on the first stage.
Stage 1 entry burn shutdown.
And then followed by a little bit of attitude gas there just to get us pointed in the re-entry attitude that we want to be in. Now, from there on, the first stage actually has those 4
Both
grid
vehicles are
fins.
following nominal trajectories.
And as we get into the thicker atmosphere, we get more control off of those grid fins. They'll actually do most of the pointing. We don't need to use attitude gas or the engines to do that until the landing burn starts in just about 40 seconds. Now, the landing burn will coincide with second engine cutoff on the
Stage 1 transonic.
second stage. Second engine cutoff expected around T plus 8 minutes, 45-ish seconds.
Stage 2, FTS was saved.
Stage 2 terminal guidance.
Now, during the landing burn, we light just a single center Merlin engine, followed shortly after by landing leg deploy, and then hopefully a soft touchdown on the drone ship.
Stage 1 landing burn.
Pretty fun coming in through the clouds here off the California coast.
Stage 1 landing leg deploy. MVAC shutdown. Stage 1 landing is confirmed.
Okay, a lot of things happened there, but I see a successful landing
Nominal orbit insertion.
of our Falcon 9 first stage We had a second engine cutoff there. You heard the call out for nominal orbital insertion. So we're in our first parking orbit for the second stage. And on the first stage, that marked the 193rd recovery of an orbital class rocket, including first stage landings for both Falcon 9 and Heavy. Now, of course, the mission isn't over yet. We've just done the first part. The second stage is embarking on its first coast phase. After this coast phase, we're going to relight that Merlin vacuum engine for a second time. That'll be around the T plus 55-minute mark.
Expected loss of signal, Vandenberg.
So we're going to leave you with some views and some space tunes. And we'll see you back here in about 45 minutes for our second engine start number 2. And there was a successful burn of the second stage engine. Super fast burn, just a couple of seconds.
Nominal orbit insertion.
And with that call out there, operators confirming that we are in the intended payload deployment orbit. Just a little bit of orbital mechanics. That initial burn that we did about 45 minutes ago was the orbit insertion burn. That put us into what's called an elliptical orbit. An elliptical orbit, there's a high point, which is referred to as the apogee, the highest point around Earth, and a low point, or the perigee. And those 2 points are different on an ellipse. This last burn actually put us into a circular orbit, roughly 620 kilometers above the Earth's surface for payload deployment. And you can actually see a couple of those payloads on your screen. We're looking at a couple of the OneWeb satellites and a view of planet Earth at the top of the second stage. Now, if you burn along your direction of travel, it turns out via orbital mechanics and the physics that that'll raise the opposite side of the ellipse that you're on. And if you notice, we're at about 630 kilometers in altitude right now. So the burn we just took raised the lowest point of our orbit into the circle. And of course, at this point in the mission, we've actually consumed a fair amount of propellant on the second stage. So Merlin Vacuum's thrust is able to give us most of the acceleration we needed to hit the desired orbital energy pretty quickly, hence that super short burn. As a reminder, the 21 Iridium and OneWeb satellites are still attached to Falcon 9's second stage. In fact, we're getting some great views of them. And we're coming up on the first payload deployment sequence at T plus about 59 minutes, so just about 2 minutes away from now. This first deployment sequence is going to have 8 deployment events, consisting of deployment of all 5 of the Iridium satellites that we're flying today, and the first 6 of 16 of the OneWeb satellites that we're flying. And we're not sure if we're going to have video coverage of the first deployment sequence, but we are expecting to have telemetry, the data, for at least the first 6 of 8 events. And that data will allow us to confirm deployment on the nets. So an operator will be reviewing...
Expected loss of signal, hard to be struck.
An operator will be reviewing the telemetry and confirming satellite deployments as we get that. The last 2 events are expected to occur during a data blackout period, and so we'll have to confirm those deployments a few minutes later when we regain ground station coverage. So again, about a minute from now, keep your ears open for those callouts of payload deployment. We'll be starting with the Iridium satellites and then moving on to the OneWeb satellites. Now, as a reminder, Iridium is a global satellite communications company. They provide access to voice and data services anywhere on Earth. After completing a series of 8 launches with us back in 2019, we're excited to be working with them again to launch 5 upgraded spare satellites on today's mission. Now, these additional satellites are going to further their constellation's resiliency, bringing the total number of spare satellites in orbit to 14 and their total number of satellites to 80. We're going to be starting with payload deploy just a few seconds from now.
Iridium 5, separation confirmed.
So with that call out there, the first Iridium satellite is away. Now, the operators on console are taking a look at a variety of data inputs to understand whether the payload has separated or not. You can typically see a little bit of acceleration on the vehicle from a payload deployment. We also typically have what are called brake wires. They are essentially connections that when the satellite leaves, sends a signal that we can interpret in data to show that the satellite has deployed. And then we do have cameras on the top of the second stage. So if there is a question about the deployment, we can usually download the data later and review that data to see if we got a visual confirmation of deployment. Unfortunately, just the way the telemetry is working out right now, we don't have live views to provide you. If you're just joining us, we're off the east coast of Africa. We're in the middle of our first payload deployment sequence. Don't have great telemetry for video, but we do have telemetry of data to confirm these payload deployments. We're in the first batch of 8 deployment events in this first sequence, starting with the 5 Iridium spare satellites that we're flying today, and then followed shortly after by 6 OneWeb satellites. Iridium and OneWeb both being our customers on today's mission.